The title of my presentation today is Evaluation of Criteria Query Towards Augmented Intelligence for Cohort Identification. This work is conducted by me and my colleagues at Columbia University, Department of Biomedical Informatics. I don't have anything to disclose. So we have this electronic health record data, which is very helpful if you want to do some screening study or to help the recruitment of patients for some clinical trials. Essentially, you can write a query for those eligibility criteria implemented in the clinical trials and use those query to search the electronic health record database to find how many patients are eligible or not. It can be used to recruit patients for clinical trials, or it can be used to conduct observational studies. So a typical scenario involves two types of people. One is a clinician or a PI, and another is a programmer or an analyst. So in this situation, Dr. Tom asked Alex, could you help me query some patients? And Alex said, yes, sure. So Dr. Tom asked, how many patients do we have in our database have type 1 diabetes? Then Alex started thinking, how can I find type 1 diabetes in the database? Should I use IC9 or maybe using IC10? But anyway, he figured out and write a SQL query. Oh, this is a number, 30,000. Then 5 minutes later, Dr. Tom has another question. How many patients took insulin for at least 1 year after that diagnosis? Alex starting query again. So insulin is a drug. So should I only using insulin to do the query? What if I'm going to lose some patients using insulin? But anyway, he figured out some way to do the query after do some search and find, okay, this is number. So here's Tom again. You get another question. Among them, how many of them have this HbA1c is greater than 6% and less than 12%? Well, Alex think, I don't even know what is HbA1c. So what does this HbA1c stand for? Let me Google it. He just Googled it, and then, oh, he find what this is hemoglobin A1c and write a query to return the number. So seems like everything solved, but the last question Dr. Tom have is, could you send me your query so I can, share with other institutions to see what kind of result they can get by the end of today? Oh, looks like that's something impossible. Excellent, because eventually, if you don't have the same database schema, how can this SQL script can be reused and works in other institutions? There's no way. So here comes Odyssey. Odyssey basically is invented some OMAP common data model. Usually we have different source of EHR data or claim data. You can convert it into the same OMAP common data model. So in that case, the script can be shared across different institutions. So in that case, Tom writes some code, and this SQL script can be shared to another institution which OMAP common data model has been implemented, which is good. But still, that's involve a lot of SQL query. Can we find something even better? So here's Atlas. Atlas basically is a web interface which can help you to reduce the amount of SQL query you need to write. You can basically click, 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 click. Then it will easily generate those SQL query for you, so that you can be used to query the database. But still, Atlas is very complicated. Most of the time, those PIs, they only want to do is just to speak some free language. So can we do even better? So here's the criteria query. Criteria query is designed to engage PIs or clinical research coordinators without any programming skills or any extensive knowledge about clinical data models. So they can just write their free language, and the criteria query will transfer this free language into computer understandable codes. So the SQL query will be generated to query the database. So that's why we call it criteria query. It's a cohort generation platform starting from free text to SQL query. It simplifies the process of identifying relevant patients in OMAP formatted patient database. It can be used in clinical trial recruitment. It can also be used to do some observational study for cohort definition. You can find the URL below. This is a typical process of criteria query. We start from some free text, and then there's a bunch of NLP components, for example, name entity recognition, negation detection, relation extraction, logic extraction. It will be then generate some JSON formats, which can be leveraged by the Atlas API to generate the SQL query, those OMAP compatible SQL query. Then this can be used to query the database and return cohort. This is a snapshot of the web interface of criteria query. You can type in the free text in this two box, inclusion criteria or exclusion criteria. Then it will pass the results, identify the relevant components, which can be later transferred to do the query. So in this example, we can say, okay, AD is something we want to do the query. And criteria query will automatically do the matching into certain OMAP concepts. And once the OMAP concept is identified, the SQL query will be generated to do the query. And you can combine a bunch of different SQL queries at different criteria together to generate a cohort. So this is the JSON format generated by the criteria query, which is complicated, but later can be digested by the Atlas to generate the cohort. So in this study, we are interested to learn how criteria query can perform in different scenarios. The first evaluation, we want to see how many eligibility criteria is actually queryable. That is, criteria query can leverage those criteria to do the parsing to do the query in the EHR database. So we randomly sampled 20 trials from clinicaltrial.gov, which leading to 278 eligibility criteria in total. We manually reviewed each of those criteria, and we found 202 out of these 278 criteria are queryable, meaning criteria query can generate a query to do the query in the EHR. Among those unqueryable criteria, 37 are due to lack of information in EHR. 10 are vague or require extensive clinical knowledge for interpretation. 29 contains intervention-associated time constraint. This is an example of lacking of information in EHR. The subject has provided written informed consent. In this case, written informed consent is not available in EHR. So criteria query won't be able to do this kind of parsing to generate a query to do the query in the EHR. So this is the example for the criteria which can be vague or extensive clinical knowledge is required to interpret this criteria correctly. The subject is an acceptable candidate for PCI. Here, acceptable candidate is very unclear, as different clinicians may have different understanding or they have different interpretation for this vague criteria. So in this case, criteria query won't be able to generate any query because it's very vague and it requires different interpretations. The third case this criteria can contain intervention-associated time constraints. In this case, the subject has undergone PCI within 72 hours prior to COPAS procedure. Because COPAS procedure is the targeted intervention, it is impossible to know when the patient gets recruited later will be given the target intervention. So in that case, we just don't know this exactly index date ahead of time. So we won't be able to determine whether this patient is eligible or not, merely look at their electronic health record data. But it is still can be useful in retrospective observational studies, as well as identify eligible patients after they have been recruited. And we do have those information in our database. The second evaluation involved in this study is to look at the real-world user-centered analysis. That is, we conducted a user-centered analysis of criteria query to see how usable criteria query is as a part of the cohort definition workshop during the 2019 Odyssey 4 Symposium. This work was approved by the Columbia University IRB. Here's the background of the participants of this workshop. We in total we recruited 57 participants. 38 have used Atlas before, which is a key component of criteria query itself. And only 5 of them have heard or used criteria query before. Most of them will identify themselves as programmer, while some of them think they are also a clinical practitioner. So in this workshop, users were asked to use Atlas and also to use criteria query to build 2 different cohorts. And after they finished these exercises, there's a survey was given to them to ask them how difficult it is to using criteria query and their feeling about criteria query. So in this survey, 1 indicates strongly disagree, and 5 indicates strongly agree. So after summarizing all the results, we found individuals tend to think C2Q is useful in general in building cohorts. And it is easy to use, but there's some issues in C2Q, especially for certain domains, including measurements, procedures. So those are the domains where C2Q does not do a very good job in terms of translating natural language into structured data queries. And accuracy is not enough in those domains. But in certain areas, criteria query is doing a pretty good job in terms of saving time and efforts in building cohorts. But for sure, we see individuals or participants, they believe helpers are needed to create cohorts accurately with C2Q if they get stuck. So here's the discussion. We believe it is important to employ machines to assess the queryability and accessibility of structured data and the complexity of eligibility criteria. Only those eligible criteria or those criteria can generate the queries should be used to generate the query. From our survey results, we found it is necessary to provide workshop and tutorials for clinicians and clinical trial recruiters to familiarize themselves with the OMA Common Data Model. Otherwise, it is still difficult to use either Atlas or criteria query. Temporal constraints can be tricky. In certain cases, for example, today is a vaguer word because we are not actually recruiting anyone yet. So in that case, we need a better comprehension for those temporal constraints in e-screening. Post-NLP human editing functions is required to improve the accuracy of the name entity recognition, especially for those domains with low accuracy, for example, measurement and procedure. In the latest version of Criteria Query, we have already incorporated these features and implement a human interactive editing interface to allow individual participants to do this kind of modification. More advanced NLP technology and large training corpus is needed to train a better NLP model to improve the NER and NLP results in the future. We recently have actually generated larger training cohorts called CHIA, which contains many eligibility criteria, manually annotated by clinicians. So in the end, this work was supported by the NLM